Hi, 8th grade. I just wanted to come at you and let you know about Pascal's principle and show you two little labs I've set up for you that we would have done had we been here, but let me read Pascal's principle to you. It says, Pascal's principle is when a force is applied to a confined fluid, the change in pressure is transmitted equally to all other parts of the fluid. So there's a few things in there. First of all, there has to be a confined fluid. A fluid is anything that flows, so it can be a gas or a liquid. And then pressure has to be applied to that fluid in a closed system, confined, can't be able to escape, and the pressure can be transmitted. So I've set up two experiments. I'm going to flip my phone down a little bit so you can see it. This one's called a Cartesian diver. So what I did was I took a straw, and I don't know if you can see it in there. It's floating up at the top, so I'll show you in a minute. I took a straw, melted the top, and then I weighted it down. So in this short little straw, all there is air. And I have a confined fluid of water here. So I have a fluid, it's confined because I have the cap on the top, I have it on tightly. And what I'm going to do is I'm going to squeeze really hard on the bottle, increase the pressure, and you can see my little Cartesian diver move up and down in there. So as I squeeze, it moves down, and as I let off, it comes up. What's inside the little straw is just air. And so and remember, air is a fluid too. So as I apply pressure to the liquid, it also applies pressure to the air inside of it. As I apply more pressure, we can see that the air is actually compressing in on itself. And so when it does that, it becomes more dense and it moves down. So let me show you one more time. So if I squeeze on the confined fluid, and you can make this at home, the air moves up and down in there, causing that little diver to become greater. If I squeeze only so hard, it'll go down a little. If I squeeze really hard, it'll go down fast, and back and forth. So a Cartesian diver. The other one I have for you is this syringe system, and in it is a fluid. It's just air, and I've connected it with just a tube, making it confined. No air can get out and no air can get in, but it is a confined fluid. And this is like a hydraulic lift. Like we would put a car on top of this for a mechanic, and then we'd press the button and the car would be lifted up, and vice versa. So you can see, this is the one that's up right now, the big syringe. So when I press it down, the force goes through the fluid and up goes the syringe. Now, picture this. This is where we put our car, on the big one, right? We wouldn't put our car on the little one. So we put our car on the big hydraulic lift. And if I press down, and I got to go a long distance in here, and I'm going to get a shorter distance here, but I am able, with very little force, to move up my hydraulic lift and lift up a car. So with a push of a button, a mechanic can lift a very heavy car off the ground. Let's show you that one more time and make one more comment. I have to go a very long distance, but I don't press very hard, and I get this to come up a short distance, which is great. So I can use very little force to move something. I just got to do a little more work by going a longer distance. Here I go a shorter distance, but I got to do a little more work, and then this moves up very quickly. So again, this is Pascal's principle. Let me read it to you one more time. When a force is applied to a confined fluid, so a fluid that's not open, confined, and we applied a force, the change in pressure gets transmitted through the fluid equally to all the parts. Again, it's how we use hydraulic lifts, and how we get to move stuff in jacks and dump trucks and cranes and all that stuff. They use this system of hydraulics, which is Pascal's principle. All right, have a great day, everybody. Hopefully I'll get to see you soon. Bye.
Bye. Bye.